Hello, welcome to 3.5. Today we're going to talk about equivalent statements and variations of the conditional statement. So the first part is looking at equivalent statements or equivalent compound statements. All right, so equivalent compound statements, and notice the symbol for equivalent. It looks like an equal sign, but it's got 3 bars. Okay, so they are statements that are made up of the same simple statements and have the same corresponding true or false values as these simple statements. So for instance, we're going to use the truth tables to show that 2 statements are true. Okay, so we want to show that P or Q and not Q implies P are equivalent, or we want to show this. Okay, so if we take a look and we construct our truth table, all right, we need a not Q because we're going to be using one. And then I'm going to construct the column for P or Q. And then we need to construct the column for not Q implies P. Okay, so hopefully you're okay with not Q. We're just negating everything over here. All right, P or Q, so true or true is where we get true, true or false, true, false or true, true, and then false or false is false. And then to fill out this column, we're comparing not Q to P. So false implies true, remember, is true. True implies true is true. False implies false is true. And remember, with conditionals, the only scenario where we get a false is when we have a true implies false scenario. So that guy's false. So you should notice that these 2 columns are the same. Therefore, those are equivalent statements. So now we're going to use this result, not Q implies P, all right, to write the equivalent statement to the point, or to the statement, I attend classes or I lose my scholarship. So that's like our P or Q. So now we're going to negate the Q implies P. So what would that look like? It would look like if I don't lose my scholarship, then I attend class. Okay, so now we're going to use a truth table to determine which of the following statements are equivalent. But before we do that, I want you to use symbols to represent the statements for A, B, C, and D if we're looking at our given statement right here. So let's suppose if it's raining, then I need a jacket is our given statement. So P implies Q. I want you to pause the video right now, and I want you to use symbols to represent the statements for A, B, C, and D below. Okay, so hopefully you had a chance to do that and that you got the symbols correct. So A, it's not raining or I need a jacket, is not P or Q. B, I need a jacket or it's not raining, Q or not P. C, if I need a jacket, then it's raining, Q implies P. And then D, if I do not need a jacket, then it's not raining, not Q implies not P. So now we're getting ready to construct our truth table to see which of the statements are equivalent. So as we kind of already determined what P and Q represent. P, it's raining. Q, I need a jacket. That means our given in symbols is P implies Q. What I want you to do right now is I want you to begin constructing a truth table. Okay, so I'm going to kind of give you a leeway here of what your columns should be. So kind of look below. I don't want to give too much away. I'll scroll through. So we need a column for our given. We'll need a not P and a not Q. We'll need our A statement, which was not P or Q. We'll need a B column for our statement, which was Q or not P. We'll need a column for our C statement, which is Q implies P. And then we'll need a column for our D statement, which was not Q implies not P. I want you to go ahead and fill out those columns, fill out your truth table, come back and let's compare to see which statements are in fact equivalent. Okay, check your truth value table, all right? And what you should notice is that our given statement, all right, has the same truth value as our A statement, which was not P or Q. which is the same truth values as our B statement, which was Q or not P, which is the same truth values as our D statement, not Q implies not P. So which statements are equivalent? The given, statement A, B, and D. Okay, now we're going to learn about another type of statement called the contrapositive. The contrapositive is a statement written by negating and reversing the antecedent and the consequent, meaning the P and the Q. Okay, so for instance, if we take a look, P implies Q is going to be equivalent to not Q implies not P. Our contrapositive is the not Q implies not P. Okay, so how do we write the equivalent contrapositive statement? So if we take a look, we write each statement in symbolic form, okay? We form the contrapositive by reversing and negating the P and the Q, and then we translate it back into words. So we want to use the contrapositive of, if you can read this, then you're driving too closely. So you can read this will be P, you're driving too closely will be Q, okay? So that is our P implies Q. That's our conditional statement. So to write the contrapositive, all we do is we reverse and negate the P and Q. So now it's not Q implies not P. So what would that look like if we are writing it back in words? It would be, if you're not driving too closely, then you cannot read this. Try example 4 on your own. Write the contrapositive of, if all students are honest, then supervision during exams is not required. Go ahead, write your P and your Q simple statement, write your contrapositive in symbols, and then rewrite it in words. Check back when you're done. Okay, so hopefully you got what I did. So you should have let P be all students are honest. Q is supervision during exams is not required. So then the contrapositive, we reverse and negate. So not Q implies not P. So if we were to rewrite that into words, if supervision during exams is required, then all students are not honest. Okay, so let's look at example number 5. Write the contrapositive, so remember, reverse and negate the antecedent and the consequent of this statement, okay? So first we reverse and negate. So this not Q goes in front, and I'm going to negate it. This not P or R goes second, and I negate that. So not Q becomes Q, and not P or R becomes P or R. So our final statement here is really Q implies P or R, and that's our final answer. Okay, we're now going to talk about 2 more types of statements, okay? And the first one is called the converse. And how do we determine the converse is we simply take the antecedent and consequent and we reverse them. So we're not negating them, we're simply reversing them. So P implies Q, our conditional, becomes Q implies P. That's our converse, okay? The next one is going to be the inverse. The inverse is where we take the antecedent and consequent and we negate them, but we do not reverse them, okay? So this is going to be P implies Q, our conditional, becomes not P implies not Q. That is our inverse, all right? So let's take a look at our first example here, okay? So if we have our conditional statement, if it's an eagle, it's a bird, okay? So that's our P implies Q portion. P implies Q, our conditional. So to write the converse, we simply switch Q and P. So now it's Q implies P. So if it's a bird, then it's an eagle. Now what I want you to do is I want you to think, is that true or is that false? And hopefully you say, well, no, that's not necessarily true. That could be false, right? I could think of a bird that's not an eagle, a parakeet, okay? All right, now let's take a look at the inverse. To create the inverse, we take our converse and we simply negate the P and negate the Q. So it becomes not P implies not Q. So our statement is now, if it's not an eagle, then it's not a bird. Hopefully you're thinking to yourself again, that's not necessarily true, right? I can come up with, if it's not an eagle, then it's still a bird. Again, my parakeet example works there. So are both the converse and inverse always true? Not necessarily, okay? And that takes us to our little note over here. Even if a conditional statement is true, the converse and the inverse are not necessarily true. So if we go back here and we look at our conditional statement, if it's an eagle, it's a bird. Well, that is true. Eagles are birds. So that's what I'm talking about here. Okay, last, what we're going to do is we're going to practice writing all of the variations of a conditional statement. So let's look at the statement. If we are in Florida, you don't see mountains. So we'll let P be we are in Florida, Q be you don't see mountains. So our conditional statement is P implies Q. What I want you to do now is I want you to fill out this table with all of the statements and what those statements would look like translated back into words. Check back when you're done. Okay, so hopefully you were able to fill out the table with no problems. So the converse is the reverse of the component. So Q implies P. If we don't see mountains, then we are in Florida. All right? The inverse, we negate the components. Not P implies not Q. If we are not in Florida, then we do see mountains. And then the contrapositive is reverse and negate the components. Not Q implies not P. If we do see mountains, then we are not in Florida. So what we can do really quickly is recognize the truth values of these statements to determine which ones are equivalent. Okay, so if we take a look and we say, okay, well, let's look at the truth value of our conditional statement. If we are in Florida, we do not see mountains. Hopefully you know that that is true. There are no mountains in Florida. Okay? If we look at our converse statement, if we don't see mountains, then we are in Florida. Hopefully you recognize that's not necessarily true. I could be in Illinois for all I know, and I still don't see mountains. Okay? We can say the same thing for our inverse. If we are not in Florida, then we do see mountains. Again, not necessarily true. Okay? If I'm not in Florida, I again might be in Illinois and I do not see mountains. And then finally, our contrapositive. If we do see mountains, then we are not in Florida. I think we know that that is certainly true. We will not see mountains if we are when we're in Florida. So what you should notice is, what are the equivalent statements here? Well, our conditional statement is equivalent to our contrapositive. Okay, so I kind of think of it this way. The conditional, con, is equivalent to our contrapositive, con, all right? And then the insides here are converse and our inverse, so I think of it as the verses. The verses are going to be equivalent. Okay, that's all we've got for today. If you have questions, let me know.